Okay, in this section, we're going to talk about section 3.3, dealing with the rules of differentiation. And in this section, we're going to be finding the derivative of power and constant functions, also find the derivative of constant multiples of functions, find the derivatives of the sum and difference of functions. Also, we're going to simplify products and quotients and find their derivatives. And then we're going to use derivatives to find slope, locations, tangent lines, and other derivatives. And also we'll find higher order derivatives. Okay, now if you recall back in section 3.1 in a video that I did for that section, I gave you the definition of the limit, where we have to use a limit as h approaches 0 of f of x plus h minus f of h, and then f of x divided by h. Okay, we have to use that definition, and we had to go through all those steps in order to find out what that derivative is. Here in this section, we're going to find the derivatives, but we're going to do it in a shorter way. Okay, so we're going to begin with the constant and power rules for derivatives, and this one is quite simple, where if you have the derivative of a constant and that constant is a real number, it's automatically going to be 0. Okay, the derivative of a constant will be 0. So it means if I wanted to find the derivative of 100, 100 is a constant, so the derivative of 100 would just simply be 0. Or the derivative of, let's say, negative 25, that's also going to be 0. Okay, and that constant can be any positive, negative number, decimal or fraction. Okay, as long as it's a constant, its derivative will automatically be 0. Now for the power rule, which is theorem 3.3, excuse me, it says here, if n is a non-negative number, that means your exponent n, that's a non-negative number, then we can take the derivative with respect to x of x to the power of n. And the way we do that is this. We bring the power down in front of the variable, copy that variable over, and it's going to be raised to the 1 less power. That's where the n minus 1 is at. Okay. Again, bring the power down, copy over the exponent, and it's going to be to the 1 less power. Like in example 1a, let's say I want to find the derivative of each of these functions, starting with part A, where you got f of x is equal to x to the 7. Now, in this case here, what I'm going to do, I'm going to use the notation f prime of x. Okay. So in this case here, we had the exponent of 7. We bring the 7 down in front of the x, copy that x over, and it's going to be to the 1 less power. Now write it out as 7 minus 1. Okay, it's always to the 1 less power. So this will be 7x to the 7 minus 1, which is 6. So the derivative of f of x equal to x to the 7 will be f prime of x equaling to 7x to the 6. Okay. Now part B, we got f of t is equal to t to the 11th power. And here I want to find its derivative. So this means f prime of t. Here we bring the exponent down, bring down the 11, copy over the t, and it's going to be to the 1 less power. We subtract 1 from 11. And 1 from 11 will be 10, so we'll end up with 11 times t to the 10th power. Okay, so the derivative of f of t equaling to t to the 11th will be 11t to the 10th. Okay, now part C is f of x is equal to negative 13. Now in this case here, we have a constant. We just have a constant, so that means we follow the constant rule where the derivative of the constant is automatically going to be 0. The derivative of a constant is 0. So the derivative of f of x equaling to negative 13 will be 0. Now, what about part D? Let's say we got g of x is equal to e to the 15th power. Now, you would lean towards using that power rule because you do have the 15 as your exponent. You would think you won't have to bring the power down, copy the e over, and then subtract 1 from the 15 to get 15e to the 14th power. That would be incorrect. And the reason for that is this. If you recall what e is, that's the natural base e. And of course, e is this, 2.7818281828, and so on. Now, of course, you can type this in the calculator. You can find out for yourself here. So if I do second ln for the e and then e to the 1, that would be that value. It's actually a constant. And let's do e to the 15th in the calculator. So here, second ln for the e, and then type in 15. And you can press enter. You're going to see, you're going to get a numerical value for e to the 15th, which is a constant. 3,269,017.372. Okay. Now, if you want to, you can write that as g of x equaling to that amount. 3,269,017.32, and take its derivative. And in this case, so the derivative of any constant is 0. So g prime of x is 0. So the derivative of g of x equaling to e to the 15th is 0. Okay. So here, this e is not a variable because here g of x, this one doesn't have an x in it at all. So your e is your constant, and the derivative of a constant is 0. Now let's look at this one, f of x equals to x. And I want to find out what f prime of x is going to be. Okay. Now I'm going to write f of x as x to the first power. And then when we take the derivative of that, f prime of x, that's going to be this. We're going to bring down the exponent of 1, copy the variable over to the 1 less power. So my exponent will be 1 minus 1, which will leave me with 1x to the 0 power. And if you recall, any non-zero number to a 0 power is automatically going to be 1. And 1 times 1 will be 1. Okay, so anytime you take the derivative of just a variable to the first power, like x, or the derivative of y, is automatically going to be 1. Okay. Now, next we'll look at the constant multiple rule for derivatives and how we can use that. All right, the constant multiple rule says here is this. If f is differentiable at x and c is a constant, then the derivative with respect to x of the constant times f of x will be equal to this. You take the constant and it'll be multiplied by f prime of x. And we have a few examples of that, like in part A, f of x is equal to negative 6x to the 10th power. And let's say I want to find the derivative of this. So this will be f prime of x is equal to, now that constant of negative 6, I'm going to pull that out in front. and then take the derivative of x to the 10th. And what I'm going to do here for the derivative of x to the 10th, I'll bring down the exponent of 10 in front of the x, copy the x over. That will be to the 10 minus 1 power. And if I simplify this, this will be negative 6 times 10, which is negative 60. And then x to the 10 minus 1 will be 9. So the derivative of negative 6x to the 10th will be negative 60x to the 9th. Okay, part B, we got g of w is equal to 5/6 times w to the 12th power. Okay, so here I want to find the derivative of g with respect to w, or g prime of w. Well, I got the constant 5/6 in front, so I'll bring that over. And then I'm going to take the derivative of w to the 12th power. And I'm going to do that by bringing down the exponent of 12, copy over the w, and this will be to the 12 minus 1. We subtract 1 from that power. All right, now let's simplify this here. That 12 is like 12 over 1. And if I divide 6 into 12, that will go 2 times. And then I'll have 5 times 2, which is 10. And then bring the w over to the 12 minus 1, which is 11. So this simplifies for the derivative of g of w equaling to 5/6 w to the 12th. It'll simplify as 10w to the 11th. Okay, now for g of t is equal to 2 times the square root of t. And I want to find out what g prime of t is going to be. So I'll write down the 2. Now for the square root of t. If you recall back in one of the videos, section 3.1, dealing with introducing a derivative, one of the examples that I did was taking the derivative of y is equal to the square root of x. And I asked you to memorize that because this is something that you're going to be seeing from time to time. And this right here, the square root of t, if you recall, when you take its derivative, is going to be 1 over 2 times the square root of t. Okay. Now, let's simplify this. This 2 is like 2 over 1. The 2's divide out. So I will be left with 1 over the square root of t. Now, in case you didn't remember that, here's the other way you could do this. I can write the square root of t in its equivalent exponential form. In this case here, this would be g of t is equal to 2 times t to the square root of t in exponential form would be t to the 1/2 power. And then apply that power rule for exponents here. So g prime of t would be this. Bring up the 2, take the derivative of t to the 1/2 power by bringing the power in front of the t, and it'll be to the 1/2 minus 1. And let me go ahead and simplify this right here, that 2 times 1/2, because those 2's divide out. So all you'll be left there with is, let's see, t to the 1/2 minus 1. That's going to be negative 1/2. And of course, I can show you in the calculator. If you do 1 divided by 2 minus 1, press the math key, select number 1 for fraction, you'll get negative 1/2. It'll be t to the negative 1/2. But if I write that using positive exponents, it'll be 1 over t to the positive 1/2. And then write t to the 1/2 using radicals, it'll be 1 over square root of t, which is exactly what I got here. Okay. So this right here is just the other way of taking the derivative, writing the square root of t as a exponent, and then use the power rule for that. Okay, next we'll look at the sum rule. Let's say we have two functions f and g, and they're differentiable at x. Then the derivative with respect to x of f of x plus g of x will be equal to this. We take the derivative of f of x and then the derivative of g of x. Okay, so the derivative of the sum will be equal to the sum of their individual derivatives. And the difference of two functions f minus g can be rewritten as the sum of f plus negative g. By combining the sum rule with the constant multiple rule, the difference rule is established as this. The derivative with respect to x of f of x minus g of x, that's going to be equal to f of x, f prime of x minus g prime of x. So here the difference of the derivative of the difference of two functions will be the difference of their individual derivatives. Okay. Now let's look at some examples of this. Starting with part A of example 3. He'll want to find the derivative for each of the following functions. And I'm just going to go ahead and do each one of these derivatives here. Let's say we got f of x is equal to 7x cubed plus 5x. And he'll want to find out what f prime of x is. Okay. So here I'm going to take the derivative of this first term and the derivative of the second term. Okay. So here I'm going to use the constant multiple rule on each one of those. So here I'm going to bring down the 7. And then the derivative of x cubed would be bringing down the 3, copy over the x to the 1 less power, 1 less than 3 would be 2. So I get 7 times 3x squared plus 5 times the derivative of x to the 1. That's automatically going to be 1. Then if I simplify this, 7 times 3x squared would be 21x squared plus 5 times 1 would be 5. So the derivative of f of x will end up being 21x squared plus 5. All right, now part B, f of w is equal to 7w to the 5th plus 2w to the 4th plus 5w. Okay, so for f prime of w, that's going to be there. So I'm going to bring down the 7. And then the derivative of w to the 5th, we bring down the 5. Copy over the w. 5 minus 1 will be 4. And then plus, for the derivative of 2w to the 4th, bring down the 2. The derivative of w to the 4th will be this. Bring down the 4. Copy over the w, subtract 1 from 4. That will be 3. And then bring down the 5. The derivative of w is just going to be 1. Because it's w to the first power, so it's automatically going to be 1. And now let's simplify this. 7w times 5w to the 4th, that would be 35w to the 4th, plus 2 times 4w to the 3rd, that's 8w to the 3rd, plus 5 times 1 will be 5. So the derivative of f of w will be f prime of w equaling to 35w to the 4th plus 8w to the 3rd plus 5. And part C, here we got f of x is equal to 3x to the 4th minus 28x plus e to the 5th. And here I want to find the derivative of that. Okay, so using a constant multiple rule, bring down to 3, take the derivative of x to the 4th, which will be 4x to the 3rd. Write down the exponent in front of the x, copy the x over, subtract 1 from 4 to get 3. Then minus the derivative of, well, bring down to 28. The derivative of x is just going to be 1. Now, what about e to the 5th? The derivative of e to the 5th? Well, that is a constant. If you recall, e to the 5th is a constant. And the derivative of a constant is 0. Because I can evaluate e to the 5th in the calculator, you're going to get a numerical value. And the derivative of any number or any constant is automatically going to be 0. Now, if I simplify this, 3 times 4x cubed is 12x cubed, minus 28 times 1 would be 28. Okay. All right, now let's look at these next few examples that I have here. In this case here, we're going to have to simplify products and quotients before we take our derivatives. Like in example 4. Find the derivative of each of the following expressions. You may have to expand or simplify the expression first. Like f of x is equal to 2x plus 1 times 5x squared plus 2. Okay, so let's simplify this by multiplying this out, and then we can take the derivative of f of x. All right, so what I'm going to do here is do 2x squared times 5x squared. That's the first term. Or 2 times 5 will be 10. X times x squared will be x cubed. And then the outer would be 2x times 2. Or 2x times 2 will be plus 4x. The inner, 1 times 5x squared. This will be a plus 5x squared. And then finally, 1 times 2, the last term, times the last term. 1 times 2 would be plus 2. Okay. Now, what I would do here is put the terms in descending power. So what I'm going to do is rewrite this as f of x is equal to 10x cubed plus 5x squared plus 4x plus 2. So I'm just rewriting this using descending powers. I do not have any like terms to combine. And now let's take the derivative of this function. So here we're going to find what f prime of x is going to be. And in this case, I can go ahead, since I pretty much know how to do it, I can bring the power down, that 3 in front of the 10, so it'll be 10 times 3 will be 30. Copy over the x to the 1 less power. 1 from 3 will give me 2. And then plus. Bring this 2 down and multiply it by 5. 2 times 5 will be 10. And then x to the 1 less power, 2 minus 1 will be 1. So it'll just be 10x. Plus, now the derivative of x is going to be 1 times that 4 would be 4. The derivative of a constant is 0. So f prime of x will end up being 30x squared plus 10x plus 4. All right, part B. 3 terms multiplied by 2 terms. 4r cubed plus 9r plus 6 times r squared plus 9. First of all, I need to go ahead and multiply this out. And then we'll take the derivative of this. So if I have 4r cubed times r squared, that's going to be 4r to the 5th. and then 4r cubed times 9. Well, 4 times 9 will be 36, and then bring over r cubed, and then we're going to do 9r times r and 9r times 9. Well, 9r times r squared will be 9r cubed. And then 9r times the 9 will be plus 81r. I need to use a different color here. Let's see, 6 times the r, because I need to multiply 6 times r and then 6 times 9. Well, 6 times the r squared will be 6r squared. And then 6 times 9 will be 54. Okay. Now let's see here if we can combine some like terms here. I have nothing to combine with the 4r to the 5th. I can combine 36r cubed with 9r cubed. That's going to give me 45r cubed. And then plus, let me put the 6r squared in front. And I'm putting these in descending powers. And then plus 81r, and then plus 54. So simplified, g of r will be equal to 4r to the 5th plus 45r cubed plus 6r squared plus 81r plus 54. And now I can take its derivative. So g prime of r is going to be this. Take that exponent, multiply by the 4 in front. 4 times 5 will be 20. Copy the r over to the 1 less power. 1 from 5 would give me 4. And then plus 3 times the 45 would be 135. Copy over the r to the 1 less power, r squared. Plus, for 6r squared, take its derivative by bringing down the 2. 2 times 6 is 12. Copy over the r to the 1 less power, it'll be r to the 1. And then for 81r, bring down the 81, but the derivative of r is going to be 1. And then the derivative of that constant is 0. So g prime of r is going to be this. 20r to the 4th plus 135r squared plus 12r plus 81. All right, next we'll look at part C. We'll look at part C. Let's say that f of w is equal to 2w to the 7th minus 3w cubed divided by 5w cubed. All right, so let's simplify this function and then take the derivative, okay? Now, I'm gonna break this quotient up as this. 2w to the 7th will be over 5w cubed, then minus 3w to the 3rd will be over 5w cubed. And then let's simplify this. I'll have 2/5. Now, when I'm dividing powers of the same base, we bring down the base and subtract the exponent. 7 minus 3 will be 4. So I have 2/5 w to the 4th. And then minus the w cube in the numerator and the denominator divides out. You'll be left with 3/5. So simplified, I get 2/5 w to the 4th minus 3/5. And now we're going to take its derivative, okay? So f prime of w will be this. Using the constant multiple rule, I'll bring down the 2/5. And then for w to the 4th, when I take its derivative, bring down the 4, copy that w over to the 1 less power. 1 from 4 would be 3. And the derivative of a constant, 3/5, its derivative is 0. So I have f prime of w equaling to 2/5 times 4w to the 3rd. Now, if I simplify that, that 4 is like 4 over 1. So 2/5 times 4 over 1 will be 8/5 w to the 3rd. Okay. All right, here's part D. G of x is equal to x squared minus 49 divided by x plus 7. All right, now let's simplify this if we can. That numerator, that x squared minus 49, is, in this case, the difference of two perfect squares, which can be factored as the sum and the difference of the same two terms. So here, that x squared breaks up as x and x. 49, what number times itself gives me 49? Must be 7. And it's a difference of two perfect squares. That means one must be plus and the other one has to be minus. And all that's going to be divided by x plus 7. So I have x plus 7 times x minus 7 divided by x plus 7. Divide out the x plus 7, and you're going to be left with x minus 7. So that means g of x is going to be equal to x minus 7. Now from this, we can take the derivative of g of x. So this is g prime of x. That's equal to, the derivative of x is going to be 1. The derivative of a constant is automatically going to be 0. So g prime of x for that function, simplified, would be 1. And part E, y equal x minus 10 divided by the square root of x minus the square root of 10. Now with this, we're going to have to simplify that by multiplying the numerator and the denominator by the conjugate of our denominator. If you remember what conjugates were, it was this. You have the same two terms, but we use the opposite side. In this case, the conjugate of the square root of x minus the square root of 10 will be the square root of x plus the square root of 10. So we're going to multiply that numerator and denominator by its conjugate, which is the square root of x plus the square root of 10 divided by the square root of x plus the square root of 10. What this is just like multiplying by 1 in the numerator and the denominator. All right, so the numerator, I'm going to leave that as is. I'm just going to write the x minus 10 in parentheses and then the square root of x plus the square root of 10 in parentheses. And this will be divided by, now when you multiply by conjugates, you're going to have the sum and the difference of the same two terms. And the way we do that is, or simplify that, would be to square the first term. And that's this, the square root of x, and you square it, will end up being just x. Because what happens here is the square of the square root wipes out the square root symbol. So you're left with x. And it's always going to be a minus the square root of 10 times itself. Or the square root of 10, and you square it will be 10. Because for the same reason, you square the square root eliminates, is eliminated. So simplified, I get x plus 10 times the square root of x plus the square root of 10, all divided by x minus 10. And now let's divide out some common factors here. That x minus 10, that's gone. I'm left with the square root of x plus the square root of 10. And from this, I can get the derivative of that function. And I'm using y prime as the notation to find the derivative. Now, if you recall earlier in one of the problems that I did, the square root of x, and you take its derivative, it's always going to be 1 over 2 square root of x. But in one of those examples, I use t. But t and x is just a variable, means the same thing. The derivative of the square root of x will be 1 over 2 square root of x. Now for the square root of 10, the derivative of a constant is 0. So the final answer for that y prime will be 1 over 2 square root of x. Okay. All right, now let's switch gears here to the derivatives of natural exponential functions. Okay, we'll start with the definition and then we'll go into the derivative of e to the x. All right, the number e is this that I just got through talking about, which is the approximate number 2.71828182845 and so on, satisfies this, which is the limit as h approaches 0 of e to the h minus 1 divided by h equaling to 1. Okay, it is the base of the natural exponent function, f of x equals to e to the x. Okay, so that's just a definition of the natural number e. Now, for the derivative of e to the x is this. The function f of x equals e to the x is differentiable for all real numbers x, and the derivative of e to the x is simply e to the x. This right here is the simplest derivative that you will ever take. The derivative of e to the x is e to the x. Okay, now we're going to prove that the derivative of e to the x with respect to x does equal to e to the x using the definition that I just gave you. All right, so now here's what I'm going to do. I'm going to let f of x equal to e to the x. Okay, now when I take f prime of x, here I'm going to be using the definition of a limit. And if you recall, the definition of the limit in the last video that I did was this: the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. That's what we will use here. Now I'm going to bring down the limit as h approaches 0. And here, this is e to the x, so the x will be replaced with x plus h. So this will be e to the x plus h minus f of x, which is e to the x. All that would be divided by h. Now I'm going to bring down the limit as h approaches 0. Now, there is a rule for exponents here. I'm going to write this off to the side. When you multiply powers of the same base, bring the base over and add your exponents. Well, we got that, but here I'm going to work backwards to get this. So here, if I have e to the x plus h, that means that e to the x times e to the h. Because if you work backwards here, you have powers of the same base, bring the base over, add the exponents. Well, this is the same as this, so I'm just working backwards here on this problem. And then I'm going to bring down minus e to the x. All that will be over h. And now the limit as h approaches 0. I always bring that down because I haven't taken the limit yet. All right. Now, take a look at this term and this term. There is a common factor. That's e to the x. That's in both of them. So the common factor, I can factor out the e to the x. This first term, I'll be left with e to the h minus e to the x divided by itself will be 1. So I have the limit as h approaches 0 of e to the x times the quantity e to the h minus 1 divided by h. Okay. Now that e to the x is a constant, it's being treated as a constant because I'm letting h approach 0, not x. H is being approached to 0. So this will be treated as a constant. So this e to the x can go on the outside of the limit as h approaches 0 of e to the h minus 1, all divided by h. Now, this is our definition of the number e, which is this right here. The limit as h approaches 0 of e to the h minus 1, all divided by h is equal to 1, which is exactly what I have right here. So I can replace that with the 1, because the limit of h approaches, as h approaches 0 of e to the h minus 1 divided by h is 1. And then, of course, 1 times e to the x will be e to the x. So here, f prime of x is equal to e to the x. Or we can say the derivative, I'll just go ahead and write it out. The derivative with respect to x of e to the x equals e to the x. Okay. And that right there is the simplest derivative that can be taken. Okay. Now let's look at example 5 on the next page. It says here that find the derivative of the following function, which is f of x equals to 4 e to the x minus 3x squared. So here's the function f of x is equal to 4 e to the x minus 3x squared. And I want to find out what f prime of x is. Well, I bring down the 4. The derivative of e to the x is e to the x. Okay. And then minus, for the second term, I have to use the constant multiple rule for derivatives by bringing the power down. So if I bring down the 2, I need to multiply it by 3. So 2 times 3 will be 6. Copy over the x to the 1 less power. 2 minus 1 will be 1. So f prime of x will be 4e to the x minus 6x. Okay, that's all there is to it. All right, now example 6. It's a 2-part example. Find the equation of the tangent line at x is equal to a. And in part B, use the graphing utility to graph the curve and the tangent line on the same set of axes. So my equation that we're dealing with is y is equal to e to the x, and my a is equal to ln of 7. Okay. So let's first evaluate f of a. And a, of course, is ln of 7. So it'll be f of ln of 7, because that's what a is equal to. And y is equal to e to the x. So it'll be e to the ln of 7. Now there's a rule for inverse properties of logarithms. If you have this, e to the ln of whatever that term is, it's going to be whatever that term is. Okay. That's a college algebra concept. that deals with properties of logarithms or inverse logarithms. E to the ln of whatever is whatever. So e to the ln of 7 ends up being 7. So my ordered pair would be ln of 7 and 7. Okay. So for us to find the equation of a tangent line, of course, y is equal to e to the x. So dy dx, its derivative is, of course, simply e to the x. And now I need to find the slope of the tangent line. To do that, it would be e to the, in this case, ln of 7, which is what we found out to be 7. So the slope of that tangent line will be 7. And then we're going to use the slope of the tangent line along with this point, ln 7 and 7 in our point slope form. So this will be y minus y1 is equal to m times the quantity x minus x1. So here we're going to have y minus, and of course, this is x1, that's y1. So y1 will have to be 7. Y minus 7 is equal to the slope, that's 7, times x minus x1, which is ln of 7. All right, so let's simplify this. This will be y minus 7 is equal to, distribute the 7 over the x minus ln of 7. This will be 7 times x will be 7x minus 7 times ln of 7 will be 7 ln of 7. And then to solve for y, we'll add 7 to both sides. So the equation will be y is equal to 7x minus 7 ln of 7 plus 7. And we're not going to be able to simplify that any further than that. So that would be the equation of the tangent line. Now for the graphing utility to graph the curve and the tangent line on the same axis, here we go. So here's my graphing calculator. I'm going to go to y equal to. Might need to clear some stuff out if you have anything in y1 or wherever. The curve is y is equal to e to the x. So I'm just going to do second ln for the e, press xt theta n for the x. I use my right arrow key to get out the exponential part. Now I'm going to go to y2 by pressing enter. And I'm going to enter this equation in y2. So it'll be 7, type in the x, minus 7, press the ln key, and then type in 7, close your parentheses around that 7, because you only want the natural log of 7. And then finally plus 7. All right, so I'm going to do zoom 6. Well, there's the graph of y is equal to e to the x. And here you're going to see the graph of y is equal to 7x minus ln of 7. Y equal 7x minus 7 ln of 7 plus 7. Okay. So here you can pretty much see that this is the equation of that tangent line. Okay. So that was part B, just on the graph. All right. The last thing in this video is higher order derivatives. Okay, and this is going to be very important as well when we get into, I would say, chapter 4, when we're dealing with, graphing functions. Pretty much you have to find the maximum and the minimum. You also have to find something like, I think, point of inflections and determining whether the graph will be concave up or concave down. That's where you use the second derivative test. So here we're going to be talking about higher order derivatives here. We're going to assume that y is equal to f of x, and it can be differentiated as often as necessary. The second derivative of f is this notation, f double prime of x, and that's going to be equal to the derivative of the first derivative of f of x, or the derivative of f prime of x. All right, so if we have integers where n is greater than or equal to 2, the nth derivative of the function would be this notation. F to the nth, f of, well, f nth prime of x would be the derivative of f to the n minus 1 prime of x. Okay, I don't think I'm reading this part correctly, but pretty much it's going to be, f n minus 1 prime of x. Now let's look at some examples of this on the next page. Let's say we want to find the first derivative, the second derivative, and the third derivative for each of the following functions. So here we're looking for f prime of x, f double prime of x, and f triple prime of x. In part A, we got f of x is equal to 7x cubed plus 2x squared plus 4x. And here we want to find its derivative, the first, second, and the third derivative. We start with the first derivative, because you have to find the first derivative in order to find the second derivative. And you have to find the second derivative in order to find the third derivative. All right, so now, f prime of x is this. Bring the power down, that's 3 times 7, that'd be 21. And then copy the x over to the 1 less power. 1 from 3 will be 2. And then plus, for the 2x squared, we bring the 2 down. This 2 will be multiplied by the 2 in front, will be 4. Copy the x over to the 1 less power. That's going to be x to the 1, or just x. Plus, the derivative of 4x will just be 4, because the derivative of x itself is 1. So 1 times 4 will be 4. F prime of x will be 21x squared plus 4x plus 4. Now we're going to find f double prime of x. We're going to take the derivative of the first derivative. So here for 21x squared, bring the 2 down, multiply that 2 times the 21 will be 42. Copy the x over to the 2 minus 1, which will be 1, so it'll be 42x, plus, this is x to the 1, so it'll just be 4, okay? And then the derivative of a constant will be 0, so f double prime of x will be 42x to the 4th. And then finally, f triple prime of x. So if we take the derivative of 42x to the 4th, well, the derivative of 42x would just be 42. The derivative of 4 is 0, because the derivative of a constant is 0. So f triple prime of x ends up being 42. And now part B. F of x equals 10e to the x. And I want the first, second, and third derivative of that function. Well, bring the constant over, which is your 10. The derivative of e to the x is e to the x. So f prime of x will be 10e to the x. Now for the second derivative of x, we'll bring that constant down. Guess what? The derivative of e to the x is still going to be e to the x. And then for the third derivative of x, bring the 10 down, the derivative of e to the x is still e to the x. And I can take as many derivatives as I want to for this function. It's still going to be 10 e to the x, because I have to bring the constant over And the derivative of e to the x is always e to the x, which is one of the simplest derivatives that you can ever take in this section. Okay, so that does conclude this video on section 3.3 dealing with rules of differentiation. Feel free to contact me if you have any questions about any of the material that's presented in this video or any of the homework problems that are in my math lab for this section.